Welcome, third graders, to the Dallas Independent School District's STEM Environmental Education Center. We'd like to give a special welcome to the students at Libby Elementary and Carthage ISD, College Hills Elementary and College Station ISD, Sky Harbor Elementary and Southwest ISD, Withers Elementary right here in Dallas ISD, and Marsalis Elementary that is also right here in the Dallas Independent School District. Thank you so much for joining us this afternoon. We're excited to have you here. We wish you could be here in person, but virtually is better than nothing, and we're going to do our best to make you feel like you're here during this virtual field trip. If you are watching this and you have not registered for this field trip yet, you can still do that by going to www.tiny.cc/EEC register to get yourself or your class registered for this field trip. We just use that information for our attendance purposes. And today's field trip is going to be about forms of energy. So during this virtual field trip, students will explore different forms of energy, including mechanical, light, sound, and thermal in everyday life. And we are going to start off this virtual field trip with an exploration of mechanical energy. Then we will explore light energy. Next, we will explore thermal energy. And last, we will explore sound energy. So we will get all forms covered during this virtual field trip. While we're doing all of that, you can ask us questions, but since this is a virtual field trip, you need to use a website. That website is www.tiny.cc/EEC-question-answer. And once you get there, you'll fill out a very short form, and you can ask us any questions you have related to forms of energy. You can ask us as many questions as you have, and we will do our best to answer all of them in the time that we have with you this afternoon. All right, let's get started with the field trip. We're going to get started with mechanical energy, and that is going to be with Mrs. Fuller.
Hi, our topic is energy, and we'll be talking about all different kinds of energy. Energy is the ability to do work. So in this segment, we're going to be talking about mechanical energy. Mechanical energy is the energy an object or material has because of its motion or its position. It is the sum of potential energy, stored energy, that's also the energy of position, and kinetic energy, that's the energy of motion. Now, this is something that's important to know. All living things and all machines use mechanical energy to do work. So we're going to start off by looking at this weight. This weighs 7.5 pounds. Now I am going to lift it over my head. And where do I get the energy to do that? That comes from the food I eat. That's stored in the cells in my body, and the muscles in my arm and my bones in my joints allow me to lift it high over my head. The food we eat, it supplies our body with what's called chemical energy, and it's the chemical potential energy. The food provides the energy for the force exerted. I'm using force to exert to lift the weight, to do the work. All right, now the object doing the work, my arm, that's the part that's lifting, is providing the force, that exchanges energy with the object, which is the 7.5 pound weight, on which the work is done. The energy acquired by the object upon which the work is done is called mechanical energy. So essentially what it means is the potential energy plus the kinetic energy, the movement part, equals mechanical energy. So we're going to put him down. And so we're going to talk a little bit about potential energy. I have a little ant, excuse me, he's on a little skateboard made out of a leaf. I've got him at the top of the ramp. Let me move him back so you can see him better. When he's resting at the top, this is potential energy. This is energy by virtue of position. He's higher here than when he gets down here. Gravity is going to be the force that pulls him to the end of the ramp. So this is potential. When he starts moving, that's kinetic. And when we get him down here, those two together is mechanical energy. So let's let him go. There we go. So we had the potential plus the movement, the kinetic, equals mechanical energy. All right, now we've got some other things here. Potential mechanical energy is energy that's stored in objects. For example, tension. Tension is an example of potential energy. So this is a spring on the top of this little monster guy. I'm going to push it down, compress the spring. And the energy be stored, potential, in the spring. When the spring releases, it's going to release a force, and it's going to throw the monster way up in the air. The motion part's called kinetic. So let me push him all the way down, and I'm going to stand back. All right, that worked out pretty good, didn't it? So the potential energy of the compressed spring, that was the potential part. The flinging way up in the air was the kinetic. You put those two together, you come up with mechanical energy. Okay, I've got another one. Here's a machine. You're all familiar with this machine. And let me get me a little thing here. All right, I've got a little piece of cardboard. I'm going to take the machine. Right now, it's not doing anything, but it has the potential for doing something, right? So I'm going to put it on the cardboard, and my hand is going to provide the energy. We're going to transfer it to the machine. The moving part was the kinetic part. The cut was the work. That was the work that got done. Remember, energy is simply the ability to do work. Okay, we've got another one. You're going to like this. Okay, when we were talking about tension in the spring on the little monster guy, we also have tension in other things like rubber bands. Have you ever cut a rubber band that was around a bunch of flowers or a bunch of newspaper, and when you cut it, it released the tension in the rubber band and went flying off across the room? Well, this is a little toy I bought. You're going to love this. They're called chicken flingers. It's like chicken fingers. And what you do, it's like a rubber band that looks like a chicken. I like chickens. So you put the chicken flinger on your finger and you pull it back. This is the potential energy part. It's stored energy. The tension is stored in the chicken. When I let it go, goes flying across the room. Let's do that one more time so that we make sure that we get the idea here. So we got our chicken. We're going to put some tension in it. That is the potential part. And then when we let it go, that was the kinetic part. It went a lot further than the first chicken. All right, here's another one right here. This is a little caterpillar toy that has a spring inside. I'm going to wind it up. And what it's doing is it's storing energy in that spring. It's got a tension. When I let it go, it starts crawling across the table. Now, it's not fast like the chicken flinger or like the jumping monster, but it still works. It still works. It's mechanical energy. Okay, now let me show you this one right here. You'll like this one too. All right, this is a top. The top has a big screw in it. When I mash on the screw, it's going to turn some cogs inside. And when it starts moving, remember the moving is the kinetic part. The potential and the kinetic together makes mechanical energy. So we've got our potential. Now here we go with kinetic. Look at the colors change. Can you see that? Colors are changing. All right. So we got several things out of that one. We got potential energy, we got kinetic energy, we got mechanical energy, plus we got sound energy. Did you see that? Did you hear that sound that sounded like a train? And of course, we got a color change too. So that's a really good educational toy right there. So we're going to stop right there. I'm going to turn it over to Mr. Broughton for any questions. Thank you.
Thank you, Mrs. Fuller. And the question that came in was, do simple machines use mechanical energy? And yes, they do. I'm going to share my screen with you real quick to show you some examples of simple machines. There we go. So you've an inclined plane is a simple machine. Another common name for that is ramp. And once you are moving your legs or body to push a box up that ramp into the moving truck, that is mechanical energy. Or a wedge is another simple machine. And if you swing an axe to split a piece of wood, there is mechanical energy happening because your body has to move to swing that axe. Or a lever also uses mechanical energy. You saw a special kind of lever when Mrs. Fuller used that pair of scissors to cut the cardboard. A wheel and axle that moves also is mechanical energy. There's screws that look like this. There's screws that look like this, or you saw the screw on that top that all use mechanical energy. And last, a pulley, where you have like a little mini wheel and axle with a rope that goes around that. You have one on your flagpole outside your school. That will use mechanical energy as well. So to answer your question, yes, simple machines do use mechanical energy. Oop, who's that guy? All right, we're going to move on to light energy now with Mr. Monroe.
Good afternoon, students. I don't think you can see me very well. My name is Mr. Monroe, and while you're on your virtual field trip with us, my part of the trip is exploring light energy. Give me a second or two. Is that better? Sure enough, it's better because we use light energy basically to see things. And we know that light energy has a lot of properties. First of all, light travels what seems to be in straight lines. Light travels much faster than sound. And we see things because they reflect light. Now, with me today, I'm going to be using several light sources for us to explore light energy. But before we get started into looking at some of those objects that give us a light source, in fact, the largest or the ultimate light source that we have today is our sun, which is a great big star of burning gases. In daylight hours, hey, we don't have to worry about light, do we? But imagine this, once the sun goes down, it gets dark, right? Well, talking about the speed of light, you know, it travels very fast. When I flipped the light switch on a few minutes ago, guess what? This light just exploded. This room just exploded with light real quick, almost in the blink of an eye. That's because light travels at a speed of about 300,000 kilometers per second. That is so fast that if you really think about it, light could travel around our planet. If it could bend around the sphere, it could travel around our planet 8 times in 1 second. That's amazing, isn't it? Students, I want you to imagine this. If you lived long ago, when we didn't have electrical lights or any type of other light source except the sun, that would be a little tough, wouldn't it? What would you do once the sun went down? Probably you would go to bed so early or go to sleep so early because you wouldn't be able to see the things around you, right? But early man, basically they used a light source that also provided heat, and that was fire. Even later on, and even today, people use something that was used a long time ago. They use candles, and it has fire to ignite the candle. And we can see that that little blaze on the candle is providing light. But we don't have to worry about that, do we? Because we have electrical energy that is converted over into light energy. You see, energy can transform itself or change itself into another form of energy. For example, this is a lamp. It has a cord on it, and if I flip it on, we have light. Of course, we've got a shade here that's taking some of the light away. Most of the light is coming through the top and the bottom. You know, out here at the Post Oak Preserve, we've got a lot of trees. And I wish you guys were out here so we could take a walk in the forest. But if the sun was shining bright and it was hot, we could cool ourselves off by maybe finding a shadow of a tree, because there are some materials that sunlight and light energy cannot go through. Trees basically would stop some of the sun's light rays, and because of that, behind that tree, there would be a shadow cast, and that would be a probably cool area, okay? Now, as far as other light sources that we use in our everyday lives, boy, there's a lot of them. For example, in my closet at my house, there's probably not enough light in there for me to find things that sometimes. And so I have several of these little portable lights in my closet. Now, unlike the lamp that's using electrical energy, I'm using also electrical energy, but it's coming from a battery that's in the base of this light. Pull the switch, the light comes on. So that is an example of a portable light. Here's another example of a portable light that we use today. Mechanics would call this a trouble light. If they're working on somebody's vehicle or automobile, you might see them have this attached to the hood while they're got the hood up and working on that motor. It's pretty bright. It would enable them to see things that they need to do to work on that motor or that engine, that car engine. And of course, we used to have camping out here, and rather than students depending solely on that campfire, if they needed light elsewhere in the campsite, they would use something called a lantern. And that lantern would look something like this, maybe a little larger. This just happens to be one that we use with our astronomy program. Now, there are other sources of light energy that have been converted into smaller light sources in case you lost something underneath a couch or some furniture in your house, or even a mechanic, if he lost a tool or something while working and he couldn't get down into the area with a flashlight or some other light source, he might use a snorkel light like this, which has a bendable cable, and he could work this down in there while he was trying to see, and then he would flip the light source on just like that. Now, I want you guys to understand that when we see things, it's because those things reflect light, okay? When the lights were off in this lab, you guys probably couldn't tell what color my shirt was. But once I filled this lab with bright light, guess what? You recognize that I had a green shirt on with white logo. So our eyes do use light energy to reflect off of the object that we're trying to see so that we can identify. And you know, I tried to set up a prism, and that prism would have told us that light basically has basic colors in it, white light. Just like you see a rainbow, those are the basic colors of white light, okay? Don't want you to forget that. Now, got one more special light I want to show you. Boy, and has this light helped me out. Listen, I know sometime or another you have gotten a thorn or a sticker in your finger or a splinter, and sometimes they're very hard to see, and you might go tell your mom or dad that you need to get that splinter or that sticker out of your, that thorn out of your finger because it hurts. And sometimes they have a very hard time seeing it or even getting a hold to it, because what they're going to use something like this called a tweezer or forceps to try to find that little splinter or that thorn to get it out of your finger. Sometimes they can't find it, but you know what? Got a special tool here. This is how light sources can really help us out in our everyday lives. At the end of this tool, there's a tweezer. Also at the end, above it, just above it, is a light source. And then what really is going to help, on top of that is a hand magnifier or a magnifying glass that's going to make things look much larger than what they really are. And so that will allow them to find exactly where that little thorn or that splinter is located, and then they can use the tweezers to pull that out of your finger, and just maybe it will stop hurting. So I don't have any more time, so I'm going to turn it back over to Mr. Broughton, and hopefully if you have any questions, he can answer those for you. And we want you guys to have a good rest of the day, especially while you're on your virtual field trip with us. I'm turning it back over to you, Mr. Broughton.
Thank you, Mr. Monroe. And the question that came in is, can we see a prism? And I don't have a prism with me, but I'm going to show you a picture of one. A picture is going to be better anyway, because it would be very hard for me to tell if you would be able to look through the prism from the camera of my laptop. I don't think I could hold it just right. But there is a picture of a prism. It is a triangular prism. Hopefully your school has one so you can use one for real. But white light, or the light that's all around us, hits that prism, and then the prism breaks that white light into the visible spectrum like the rainbow. So it goes from red, orange, yellow, green, blue, indigo, and violet. A way to remember that is Roy G. Biv. And since you are with us, we're going to even go way past third grade level and right to high school astronomy level. If you want to know the wavelengths, violet is 400. And then if you get up to red, you're at 750. And so you will need to know that when you get to high school. So maybe you'll remember that years down the road, and we'll have helped you out a little bit. But now it is time to get to our exploration of thermal energy with Mr. Ramirez.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about thermal energy. Thermal energy is also known as heat energy, and heat energy is simply energy that makes things warmer. Typically, heat will move from things that are warmer to things that are cooler. So in this segment, we're going to be looking at examples of things that provide us with thermal energy that we use in our everyday lives. So we're going to start off with some very common kitchen appliances that provide us with nice thermal energy. And as I show you these kitchen appliances, be thinking about how we use these, or how you use these items in your everyday life, and how and why you use them. So here's a good example of a toaster. It's using electrical energy, and it's simply converting electrical energy into heat energy. So if you have a slice of bread, when you take it out of the package, it's kind of flimsy and soft. When you put it inside the toaster, how does it change? So it turns into that nice, crispy, crunchy piece of toast. Another common kitchen appliance that you guys probably have, this is a portable version of one. This is an electric stovetop. Again, it's converting electrical energy into heat energy. And we can use this to heat up some common foods like rice and pasta. Now, when we cook our rice and pasta, when it gets heated in boiling water, it starts to soften and get longer, and that's how we can enjoy our noodles. The next appliance that we probably use in our everyday lives, I know I use them a lot during the winter time. This is an electric heater. I have these in pretty much every single room because I like to stay nice and warm. And then another type of device that provides us with thermal energy during the winter time is a nice thermal blanket. So this thermal blanket is different than a regular blanket because it's actually connected to an outlet, and it's using that electrical energy and converting it to heat energy. There are wires throughout this electric blanket, and it keeps me nice and warm. I actually put a thermometer inside this electric blanket, and it's about 115 degrees Fahrenheit right now. So this blanket is keeping me nice and warm. And I love using these during the winter time. It's probably my favorite Christmas gift that I've ever gotten. Now we're going to compare this electric blanket to a regular blanket, or to a coat or jacket that you guys are probably going to start wearing here since it's the season of fall and the weather's getting cooler. So now, do you think a regular blanket or a coat or jacket, do you think those things provide us with thermal energy? Why or why not? So the answer to that is no. So coats and regular blankets are insulators. They do not provide or give off thermal or heat energy. Instead, they keep us warm by trapping our body heat. So what ends up happening is our body is constantly losing heat to the cooler air or outside environment. So when I put on my shawl or if I put on a coat or jacket, as my body heat is being lost, it's actually trapping that body heat and helping me to stay warm in that way. But it's not actually generating electrical or heat energy like our thermal blanket is. So that's the difference between those two. Now, the next thing we're going to take a look at is a common toy that you guys probably have, and it is a lava lamp. So here's one example of a lava lamp. You can see the glitter inside is constantly moving up and down. And then we're going to take a look at another lava lamp. This time I'm going to use our safety procedures. I'm going to put on some oven mitts because this lava lamp gets a lot hotter. So this lava lamp, the way it uses thermal energy, there's a bulb inside. That bulb gets heated. When that yellow fluid comes in contact with that hot bulb, it's going to start to get hot. When things get hot, they start to rise. And you can see that blob starting to rise to the top. Once it reaches the top, because it's further away from the warm bulb, it's going to start to cool down. And when things cool down, they start to sink because they get more dense. So as you can see, this little blob over here is starting to sink. And then once it reaches the bottom, guess what? It's going to get warm all over again, and the whole cycle will continue. And that is how we see the constant movement of liquid and other objects in our lava lamps. It's that continuous movement between hot and cold. Now, we call this convection, and convection currents are actually responsible for hurricanes. So that's our lava lamp. Another toy that you guys might be familiar with is a color changing board. So y'all probably played with these when y'all were younger. A lot of the younger kids use them, and they use their fingers to write with. So this has a heat sensitive film. If I take my hand, again, my body is releasing body heat. If I take my hand, since this is a heat sensitive board, I should be able to leave a hand imprint on this board. And you can see my hand right there. Now, the next thing we're going to look at is how our animals here at the Environmental Center depend on heat or thermal energy. So I have an animal friend to show you guys. Her name is Pelota, and she is a ball python. They get that name because when they are scared, they will curl into a tight ball. Now, a lot of our reptile friends depend on thermal or heat energy for their survival. Now, she's cold-blooded. And all that word means is that cold-blooded animals cannot maintain their body temperature. So if she's feeling cold, she's going to have to move and find someplace nice and warm. If she's feeling too hot, she's going to have to move and find shade or someplace to keep her cool. Now, we are different. Humans are mammals. Mammals have the ability to maintain their body temperature. Our body's pretty good at regulating our temperature. So I'm going to go ahead and put Pelota down. She's very active right now. You can see her smelling with her tongue. We're going to go ahead and put her down, and I'm going to show you an example of how we help to regulate her body heat. So let me go ahead and close her container. I'm going to move my laptop just a little bit so you can see. This is an example of a terrarium. A terrarium is a place where our pet reptiles live. So you might be familiar with an aquarium. An aquarium is filled with water, and that's where we put our fish or aquatic animals. Terrariums are for our land animals. And you notice that we have a heat lamp. So inside this lamp is a bulb that gets super hot, and it provides heat energy or thermal energy for our reptiles. So if we have a reptile in here, if like a turtle or a snake, when that animal is feeling cold, all they have to do is just migrate over to the heat lamp side, and they will bask or lay underneath the heat lamp to stay warm. Once they're warm enough, they have the ability to move back and go to the other side where it's much cooler. Now, I actually put thermometers inside so that you guys can tell the difference in temperatures between each side. The side that is under the heat lamp is about 100 degrees Fahrenheit. So that's about the temperature on a hot summer day. The other side has a temperature about 75 degrees Fahrenheit, so just above room temperature. And I can tell by using my senses of touch, just by feeling the glass, I can feel a difference in temperature. Now, since y'all aren't able to visit us this year, I actually took some pictures of some other animals at the Environmental Center that depend on thermal energy. So I'm going to start the process of sharing my screen. And once we get that started, I'm going to show you guys some pictures of some of our other reptile friends. So the first reptile friend I have for you guys is a box turtle. And you can see he's enjoying basking underneath his heat lamp. This is a red-eared slider. They get their name because they have a red patch of skin around their ear. This is a prehensile-tailed skink, and he's enjoying his night light. This is a close-up of the prehensile-tailed skink, and I said these guys are all reptiles. You can see their dry, scaly skin. Now, this one's not a reptile. It is actually a bird, but it is warm-blooded, just like us. And because this little bird, it's a baby chick, because he's too young, he actually needs extra thermal energy. So he needs an extra heat source. So that's why he has a heat lamp to keep him extra warm while he's still young. And there's a close-up of that little baby chick. And then this last picture is a picture of our lake across the street. And you can see our sun. The sun is the most important energy source and heat source that we have outside in the wild. So the sun is very important, providing heat for our wildlife. It's very important for light energy for our plants to grow. And it also helps to drive our water cycle. So you see our wonderful lake there. So I'm going to go ahead and stop our screen sharing, and we're going to go ahead and close up and wrap it up. So the last thing I have for you guys, I just have a quick reflection question for you guys. So we talked a lot about thermal energy out here at the Environmental Center and with common things that I use. So I have a reflection question for y'all. I want to see if y'all can give 3 examples of how you or a parent or an adult in your household uses thermal energy today. So think about the things that you did today and how thermal energy was used. And that's all I have for you guys today on thermal energy. We're going to go ahead and give it back to Mr. Broughton, and he's going to answer any questions.
Thank you, Mr. Mears. The question that came in was, how does heat make things rise? And we'll use a hot air balloon for an example. And weather works the same way. If you heat up some air, it's going to expand or get bigger, and then that makes that air less dense than the colder air. If something is less dense, it will float. If something is more dense, it will sink. So that hotter, less dense air floats up into the sky, while the colder air that's cooler stays lower. So that's how heat can make things rise. All right, now let's get to our last form of energy, sound energy, with Miss Nash.
Hello, welcome to my classroom. Today we are talking about sound. And if you can hear me, you can hear sound. So I was listening to my ocean. I hear it. And is there really an ocean in here? No water coming out. I don't think so. But what's happening? We're going to try to figure that out. So sound is the kind of energy you can hear. Sound is made from vibration. Big word, vibration. Sound is vibration. Sound is vibration. To vibrate just means to move back and forth. And you can see my paper moving back and forth, and you can hear a sound. But what you can't see is the fact that as I move the paper, it's making the air move. Little bits in the air, the molecules in the air are starting to move too. And they move all around the room. Someone in the very back of the room could hear that sound also. It's going through the air. So sound moves through the air for us to hear with our ears. Sounds can be different. They can be loud, loud or soft. We call that volume, the volumen. And on your TV or your radio, you've got a volume. Or your computer, you have a volume. Now, so we can experiment with that too. Loud and soft. I think I turned that off. Turn off. There we go. Sorry. Now, we can also experiment with pitch. So sounds can have a high pitch, high or low, tonal, high or low. And again, you can do little experiments with that to see how it works. So one thing that's fun to do is to get a box and some rubber bands. And then you stretch the rubber band all the way around the box. And then you can pull it tighter or looser. And then the tight one, a little slower. You can change the pitch up and down, depending on how tightly it's strung. Okay? So you can kind of see, when you look at it, you can see this one's vibrating faster, this one more slowly. So this is how all the stringed instruments, the guitar, the violin, the piano, all the stringed instruments work like this. And it's a fun thing to experiment with, see if you can change the pitch. So for us, most of the sound we hear moves through the air, but sound also moves through the water and to liquid and to solid. So it moves really well through the water. So whales can sing, and another whale can hear it under the water 100 miles away. And you can see this around us too. So on a foggy day with little cloud down here on the ground for us, with little tiny water droplets, you hear a sound, a train whistle maybe, far away. You'll hear it really well. So a foghorn, it's a big horn they put up on the edge of a coastline. And so if you're a sailor and it's a foggy day and you can't see anything, you can listen for the foghorn. And then you'll know you're too close, stay away from the rock. You can also experiment with a glass bottle like this by filling it with different amounts of water. And then you can hear a difference in pitch again. So that's another fun experiment you can do to see if you can make different pitches. Now, we hear sound because we have ears. And inside your ear, way down deep inside, is what we call the eardrum. And it's like a drum. It's all a drum. And I can beat my drum. So it's got a piece of skin, animal skin, around the top. And it's stretched tight. And when you hit it, it reverberates inside. So inside your ear, there's a tiny skin like that, the drum in your ear. And that's what helps you hear. It transfers the vibration from the air into your other structures and then over to your brain so you can hear. So it's important to protect that eardrum because it's tiny, tiny, and it's delicate. So if you have really loud sounds, they can be good in some ways if they're alerting you sometimes to danger, like the fire alarm or the fire truck that comes by telling you danger, danger. But it can also hurt your ears. So when it goes off here at work, I put my fingers in my ears. I can still hear that noise going off, but I can protect my ears. When people are doing work with machines that make a lot of noise, they wear those ear protectors. And the teenagers who have their headphones on listening to the loud music, they should turn down the volume to protect their hearing. Okay. Now, other animals can hear sounds that we can't even hear. So a bat, for instance, look at the big ears on this little free-tailed bat. And they use really, really high-pitched sounds that we can't hear to bounce off tiny insects and catch them as they fly around. Look at those ears, amazing ears. So even a dog or a cat, a wolf and a bobcat, but your dog at home and your cat at home have those big ears that catch the sound really well, and they can turn them to get the sound better. Have you ever seen them do that? And they can hear sounds that we can't hear. High-pitched or really soft sounds that we can't hear. Owls also have great hearing. They can hear a mouse under the snow. They can hunt in total darkness just by listening. Okay, so these discs around their eyes help funnel the sound to their ears. The ears are under the feathers, but they're really, really good hearing. Really good. Okay, so I have a couple of things I'd like you to think about doing later on today or tomorrow or whatever. go around the house and see if you can find something that's making a loud sound and something that's making a soft sound. And then draw a picture of that thing and think about why are they making that sound. So at my house, I went around and the dog is making a loud sound. The dog is barking loudly. Why is the dog barking? Because someone is knocking on the door and the dog is telling me there's someone here. Quick, open the door. Let me jump on them. The cat is purring softly. Have you ever heard the cat purring? And why are they purring? The cat's happy. Okay. It makes me happy to hear that sound too. It's a really sweet, soft sound. Another really great thing to do is to take a walk and go to the park and sit down somewhere quietly, close your eyes and just listen. And you'll hear all kinds of things all around. You'll hear the leaves in the trees with the wind rustling. You'll hear the birds singing, the insects calling, all kinds of interesting sounds out in the park. And then you can come home and draw a picture and put in all the things that you heard, okay, in addition to the things you saw. And then you can try to make your own musical instruments at home. It's really fun to go around the house and see what you can make. My favorite one that I invented with two plastic cups and some chopsticks inside, and it makes a really good sound like that, but also makes a really good noise like that. Okay? Really loud, different. Next different one. You can make a telephone. Prove to yourself that sound will move through a solid like this rope. And it's also a good socially distant activity. You take 2 tin cans, clean them out. They still smell like tomato, but I washed them. But if you cover, you got to cut yourself on the sharp edges and then tie a rope. You have to get an adult maybe to help you with a big nail and a hammer to make a hole in the top, and then stretch it out with a friend or family and whisper in one end, and they can hear in the other. And you can experiment to see better kinds of rope, better kinds of telephone parts, cans. I tried it with paper cups because they were really easy to make a hole in, but they did not work nearly as well. So you can do some little experimenting to see what works better. Now, back to our seashell. See what's happening with our seashell. This is one of my favorite sounds. So got the big round space inside, and when I hit it, the sounds are kind of reverberating. They bounce around inside. And that's what's happening with the seashell. If you look inside, it's hard, like hard surface. You can hear how hard it is. And any sound waves in the room are getting caught in here and kind of bouncing around. And then I can hear them. And I can imagine them at the ocean, even if I'm really not. So I hope you had some fun with sound and other kinds of energy today. And I'm going to turn it over to Mr. Broughton if you have any questions you can ask him.
Thank you, Ms. Nash. The question that came in was, what materials make the best tin can telephone? And like Ms. Nash said, you should that would be a good investigation that you could do at home or at school. One suggestion I will give to you if you do that investigation is to try fishing line instead of string. Try string too, but also try fishing line and see how that works. It's kind of interesting. I'm going to share my screen with you real quick to recap what we did today. And there we go. Today, we did explore forms of energy. During this virtual field trip, we explored different forms of energy, including mechanical, light, sound, and thermal energy in everyday life. So we started off with that exploration of mechanical energy with Mrs. Fuller. Next, we explored light energy with Mr. Monroe. Then we explored thermal energy with Mr. Ramirez. And you just saw Miss Nash exploring sound energy. And now you can explore those forms of energy at home as well. Thank you so much for joining us this afternoon. We really appreciate you taking the time to visit our center virtually and learn about forms of energy with us. And we would like to know what you thought about today's virtual field trip. You can let us know by going to www.tiny.cc/EEC feedback and filling out a short form. It takes 1 maybe 2 minutes at the most to fill out, and you can give us feedback on how we did today, and we would appreciate it. You have a great rest of your day, and we hope to see you next time in about 3 weeks. Goodbye.